Yeah, whoa, whoa, you said you wanted more dog videos. Here we go. And my wife's British accent. What?
Peter training his dog, Maximus.
He's so cute. Look at him. Oh, oh, oh.
And there's Rory's friend. Oh, he's gonna jump hopefully on the top one. Oh, he's doing a jump anyway.
Yeah, good boy. Go Max. Best dog ever. Woo. Thanks for watching. Nice. So then we're helping you today with solving trig functions. Nice. So number one is undefined, does not exist. Cool. And then we have, let's see. Thanks, Jesse and Selene. Name drop. And Annie, thanks for staying after, turning in your worksheet, your homework, as well as Kyler, name drop. Yeah, Ethan, thanks for staying and filling out your unit circle, what you're supposed to do in class, but you did it, so you could go. Nice. So we learned this today. We learned that cosine of theta is equal to 1. Oh, so first of all, number 1 is undefined, does not exist, because there is no 2 on the unit circle. No 2 on the unit circle. But there is definitely a 1 on the unit circle. And so cosine and then sine, do you remember those positions? So cosine and sine. So we're going to use those today. And so we're basically inverse cosining. We're trying to figure out what the angle is that makes cosine equal 1. And so what we do is we go to our filled out unit circle, so make sure you filled that out. And we're going where cosine equals 1, which right here, cosine equals 1. So then we go over here to the degrees and we say 0 degrees. Or let's see, is that it? What about over here? Where cosine, oh, that's negative 1. Nope, nope, nope. But if we did have a question like that, could you say it was 180? Yes, you could. And so that was our example from Selene that she came up with. So at 180 degrees is where cosine equals negative 1. Cool. And then we figure out the tangent is sine over cosine. And so to get a negative 1, we'd have to be something over something that equals each other. So in this case, radical 2 over 2 divided by radical 2 over 2. For number 3, inverse cosine to the other side. So the calculator gives this answer, but does not give you both answers. So that's why we need to use the unit circle as well as the chart that we're going to show you next time. Unit circle. And then we also have a chart that we're going to fill out next time together as well. And so that chart is going to look like this guy right there, right? So definitely take a look there and use that chart. But you can use unit circle on these for now before we do that chart. Cool. Okay, so I was asked to do number 13, 18, 19. So number 13 video, there it is. Okay, so then this is kind of a harder one. So let's take a look at that there. And so before we do the harder one, let's actually take a look at number 3 just to make sure you know how to do this. So where is cosine equal to negative a half, right? That means cosine is going to be in the negative a half position because it goes cosine and sine, right? So go to the unit circle. Can you find it? So where's cosine in the negative half position? You're right, it's right there. Cosine negative half position. So we write down 120 degrees if they want the degree, or 2 pi over 3 if they want the radian. And then down here, at cosine equals negative a half, and that came from the angle 240 degrees. Or if we wanted the radian, we'd say 4 pi over 3. So you'll notice on the homework that the first 4 use degrees, and the last 4 asked for it in degrees, right? 0 to 360. Awesome. And then radians is what we're going to do now. So let's jump to a harder one, number 13. Okay, so we want to get everything else to the other side except for the cosine. Ooh, 13's all set up. What? So what we want to do is we want to just treat this as without the 5 pi over 6, and then we'll come back to it. Let's just first find the answer of where cosine equals a half, okay? So you tell me. I'm waiting. Yeah, you behind the screen. Yeah, you. Don't just watch. Stop sitting there. Come on. That's it. So go to your unit circle, and can you spot it with your eye? Can you spot it with your eyeball? Where is it? Where is cosine equal to a half on the unit circle? Right? I'm testing you. Yeah, did you figure it out? Circle it. Did you figure it out? Good. So we're looking for the cosine position. So here's the cosine position equal to a half. Now, do we want a half or negative a half? Let me double check. That's right, just regular half. Because it does. Does it make a difference? Yes, it does. Okay, so cosine of a half gives us 60 degrees or pi over 3 radians. So we're going to write that as one of our answers. So all students take calculus. So cosine is positive in the all part in the first quadrant, and where also is cosine positive? Can you figure that out? Nope, over here cosine is negative. That's the second quadrant. But where's cosine positive? Well, all students take calculus. C, cosine is positive in quadrant 4. So now we look for positive 1/2. Can you find it? What's the radian? Say it out loud, I can hear you. Say it. That's right, good job. So cosine of a half is going to be 5 pi over 3. So there's our two answers, pi over 3 and 5 pi over 3. So now we go to problem number 13. And so now we say that cosine, so basically what we're doing is we're inversing cosine by getting those two answers. Inverse cosine of a half. And so we're getting theta is equal to, let's write it the other way, I don't know why this problem's backwards. So theta is equal to, what are the two answers we got? So we got pi over 3, and we also got 5 pi over 3, right? Nice. And that's where cosine is at a half, positive a half. Cool. So now we're going to deal with our original part, and that was, we didn't just have theta, we had theta plus 5 pi over 6, right? So we initially just ignored that. So ignore initially. And then we have to go ahead and deal with the plus 5 pi over 6. So now what we're going to do is we're going to write theta, which was our original, and now we're going to go ahead and do the plus 5 pi over 6. And so we have theta equal to pi over 3, and we have theta equal to 5 pi over 3. But now we have that 5 pi over 6 in there, right? Because cosine is gone. And so now we're just dealing with this guy. And so now, how do we get that 5 pi over 6 to the other side? What do you think, Annie? What do you think, Kyler? What the? Oh, yeah, they're gone. Come back. No, have a good weekend. Enjoy prom. So what do we do to the other side? We minus 5 pi over 6 minus 5 pi over 6 to the other side. So we're going to go ahead. Oops. So minus, it's those two, sorry. So minus 5 pi over 6. Not add it, we're going to minus it, right? Because we're trying to get it over to the other side of the equal sign, right? I don't think you like all those crossing outs, do you? So I just back up a little. There you go. That's not what I wanted to do. That's not really what I wanted to do. Okay, so round number 13. Good. Thanks for your patience. Wow, the smartboard is, it's Friday. It's just acting up, okay? Okay, good. So now we're going to take 5 pi over 6. We're going to minus it to the other side, because if you do it to one side, then you have to do it to the other side. Good. Minus it, 5 pi over 6 to the other side. Good. Okay, so then stinking not the same denominator. That's okay, we can fix that. Okay, so what we're going to do now is we're going to go ahead and get this to become a 6th. So how do we get that to become a 6th? We times it by 2, right? To the bottom and the top. So this becomes 2 pi over 6. And now we can combine those. So 2 minus 5 is negative 3 pi over 6. Nice, because 2 minus 5 is negative 3. Pi over 6, which reduces to negative pi over 2. Good, good, good. Not even pi over 6, sorry. Good. So there's one of our answers. And then we have to turn this into a 6 by multiplying it by 2 to top and bottom. So that becomes a 10 pi over 6 minus 5 pi over 6 equals still 5 pi. Oh, equals 5 pi. Yep, over 6. Positive, though. Positive. Cool. So those are our two answers. Nice. Now, this is fine. I'll accept that as your two answers. However, the instructions do say to have everything between 0 and 2 pi. And so that means they all have to be positivo, positive. And so that means that theoretically our negative pi over 2 for number 13, negative pi over 6, sorry, for number 13, really you need to go around the full circle once, right? So this is just for 1060 now. You don't have to do this. But if you want to, you're supposed to go all the way around. No, that's backwards, new build. Oh, yeah. So really we want to make it into positive. And so we would have to go all the way around and figure what that angle is. And so that's actually 11 pi over 6 would be, I think, the right answer for that one. And but really, we'll go ahead and take those two of the answers. Yeah, because basically you have to do the coterminal angle, which means you have to add by 2 pi to make it positive. And then you got to turn it into a 6, so times by 6 on the bottom and the top, that becomes a 12. And 12 minus 1 is 11, or just that angle right there. Cool. So that's adding, remember the coterminal, positive, negative coterminal angle. And so, but we'll just accept negative pi over 6 and 5 pi over 6 if you want. If you do put 11 pi over 6 for this one, I'll give you full points. You want me to say extra credit, huh? But maybe not on 13, but maybe on a different one might give you extra credit. Sick. Okay, so there's number 13. We're going to jump down to number 18 next. That looks like a fun one. Okay, so then we're going to divide by negative 1/3 to the other side because right now they're being multiplied. And now we have cosine of theta plus pi over 6 equals. Now we can go ahead and times it by 3 over 1, 3 over 1. That'll cancel lots of things, leaving us with just, negative divided by negative is a positive. Radical 2 over 1, which you could just say is radical 2. Ooh, interesting. So the reason why 18, I did this on the video, is because I think it was in 6th period. Name jog 6th period. So we were looking at that, and we were like, what the heck? How in the devil? Yeah, so we're like, where does cosine equal radical 2? And if you look at the unit circle, there's radical 2 over 2, but there's not just a radical 2 over 1 anywhere. So that's like, nah. So then I looked at the answer key, I'm like, where did I go? How do you figure out radical 2? I don't know, it's not even on the unit circle. And then I found out the reason why. Stupid! So it does not exist. This one is undefined because there is no radical 2 by itself on the unit circle. There's a radical 3, but not a radical 2. Yeah, because radical 3, where'd that come from? Oh yeah, we did it right there. Maybe you'll need that. Whoa, that was a weird line. That was weird. Yeah, this smartboard's ready to cry. We'll have to go sleepy by, but not yet. Drew that line. Yeah, so that's sine over cosine. Negative radical 3 over 2 over half. That reduces to negative radical 3. And you might need that on one of these problems, maybe 14 or 16. Okay, so 18 doesn't exist. We're going to jump to 19 next. Okay, so 19, you want to get everything on the same side. So now we're going to have to add 4 to the other side. Good. And so when we add 4 to the other side, wow, you're going to get a minus 8 minus radical 2 over 2. You're going to add 4 to the other side. That's what sine equals. Remember, we're kind of ignoring this for now, just for a second. Then we'll minus 5 pi over 4 in the end. Okay, wow, so this is challenging. So we need to turn 4 into halves. How do we do that? Well, we give it a half. Ta-da! No, if you did that, you actually wrote 4 over 1. Oh, really? Yes, you did. Oh, yeah, that's right. And so then we times it by 2, and if you times it to the bottom, you have to do the top. So 4 is the same as 8 over 2, right? Because 8 divided by 2 is 4. So that works. That 4 becomes an 8 over 2. And then we can go ahead and combine it with the minus. Right? Minus radical 2 over 2. You following along there? So we can combine that. So now we have 8 minus radical 2 because they have the same denominator. So we can write it all over 2. And guess what happens to the 8s? They cancel, silly old bear. So we got negative radical 2 over 2. Ooh, that's a famous one on the unit circle. So negative radical 2 over 2, where does that equal for sine? Right, inverse sine to the other side, solve for theta. So what angle uses sine? All students take calculus. So not the students, that's where it's all positive, but down below, third and fourth quadrant is where sine is negative radical 2 over 2. Can you find it? I know you could. Can you find it? So I found it. Here's sine, negative radical 2 over 2. So we're going to use 5 pi over 4. And then here's another negative radical 2 over 2 in the sine position of the coordinates. And so we'll use 7 pi over 4. Cool. So 5 pi over 4 and 7 pi over 4 is what we're going to use there. There we go. So that's what theta equals. So theta equals 7 pi over 4 and 5 pi over 4. Nice. Nice. Okay, so then we can now stop ignoring me. I'm over here. Oh, hi, there you are. So don't forget we have 5 pi over 4 with that theta. And so then you're going to pretend it's, over here and stuff now. And so what we did was the inverse did, so the sign went to the other side and disappeared. And so now we have to minus, right? Do the opposite sign, or opposite thing, opposite sign. So now we have to minus 5 pi over 4 to the other side. And so now we get 0. Theta equals 0, and then 7 minus 5 is 2. Pi over 4, 4 comes along for the ride, which is pi over 2. So we have 0 and pi over 2 for number 19. Sweet. So that's for number 19. Awesome possum. There we go. Double checking that brother there. Yep, 0 and pi over 2. Beautiful. So we got number 19 right. Okay, so here's number 20. Oh, nope. We're going to have you try that on your own. So we're going to do number 21 and then 27. Cool. Ooh. So 21, we got lots of stuff going on here. We're going to have to combine some stuff. You got this. It's not that bad, I promise. So let's get all the tangents on one side. So let's go ahead and add this 2 over to this side. So 2 with the negative 3 is what? 2 with the negative 3 is negative 1. Maybe we should do a new video for 21, 27. I feel like it's too long. Darn it. I don't see where the time elapses. Yeah, 17 seconds. Sorry. Okay, watch my next video. Peace out. Please tune in for my next video. Thanks for watching.